Hello and welcome to Hersley. I'm John McNamara and I'm here today with David Radley. Hello, David.
Hello.
Hello. And we are honoured to have with us today the awesome Sarah Connell. Hello, Sarah. How are you?
Hello, I'm good.
Good, good. So, Sarah, you're doing some really interesting work. Can you give us a quick overview of what it is?
A few years ago, I was working on the IBM Cloud Orchestrator project, Smart Cloud Orchestrator as it was in the time. And I decided to do a part-time master's in cloud computing in the local technical college here. I think it's actually one of the first cloud computing courses in the world at the time. So, and I was the second stream to be part of that. And of course, doing a master's, you have to do a thesis. So the idea of what to do for my thesis came up, and I spoke to an STSM, a local STSM here in Cork, called Willie Duchesnay, looking for ideas, and as I said, working with Cloud Orchestrator and open source products such as OpenStack. We kind of looked at doing something related to OpenStack, related to open source. And Willie actually had a really great video that was on YouTube. It was a virtualization of the history of OpenStack development as it was, and it showed how the projects were expanding in a really kind of cool virtualized way. So this kind of brought up the idea of, well, how do you actually measure the health of an open source project? And if you're actually going to adopt an open source project, how do you choose which one to go for if there are competing technologies out there? So I guess that's where all this started.
Awesome. So I guess that conversation and your master was kind of where the idea initially came from, was it?
Yes, exactly. So that's exactly where it came from. So it grew from the idea of working with open source, and then looking at the projects and comparing different life cycles and being able to determine the health of a project, and to see, was it active in the community? Is it worth adopting, from IBM's point of view? Especially because when you look at OpenStack, there are competing technologies such as CloudStack, but OpenStack has really, come out as number one, and, trying to determine how that actually happened was kind of a really interesting goal that we set our sights to.
So how did you decide to get the data? What data did you decide to use to make those sort of decisions?
Yeah, so so I looked at GitHub as the repository of the data. So GitHub would be probably the main code hosting platform online at the moment. There are millions of projects hosted on GitHub. At the time I was working with it, I think there were 4 million users on it, and at least 2 million repositories. So absolutely huge data set to work with. Now for my thesis, working with 2 million projects was probably out of the question. This was kind of a proof of concept in a way. So what I did was that I had to limit the number of projects I was going to analyze and work with. So what I did was that I immediately limited the number of projects to JavaScript only projects. This is probably one of the largest number of projects stored on GitHub, so I knew there would be a large data set already there. And I think with JavaScript projects as well, you're quite often comparing like with like. So you can have quite a large project, quite a small project, but they can be equally successful and equally important in a way. So I think there were, trying to remember, about 250,000 JavaScript projects at the time stored up there. So what I did was I started looking at the projects and analyzing the projects that were actually stored up there to see which ones I should look at. And first of all, I limited projects that had only 18 months of a development life cycle. Sorry, at least 18 months of a development life cycle, because I felt any less than that, you could be getting a really fast trending new project that could kind of skew your data results. I also looked at projects that only had, or that had at least 100 stars, because looking at projects that had less than 100 stars in more detail, and they were turning out to be kind of hobby projects or test beds, or just these kind of sample projects that developers were putting up on GitHub, but not really serious projects that were actually people wanted to deploy and use.
So you had a So you had you feel you got a good sample, a good representative sample, and what did you do with that data once you got this project? Presumably you got different bits of data from those projects.
Yeah, yeah, exactly. So I suppose the next step, as part of a master's degree, there would be a research side to it. And the research side to this was to actually look at the literature and to see, what other researchers out there had, already studied open source projects and maybe software projects in general. So, closed system traditional projects, and look at the metrics that they had actually already defined. So there were a number of researchers that I would have focused on, and they would have come up with things like, when you're measuring a closed system, you're looking at the project output, you're looking at the code quality, you're looking at maybe how many downloads or how many people have actually bought the product. Whereas when you're looking at open source, you're looking at the project activity itself. So you don't necessarily know how many people have downloaded this project because it might be available on different sources. And you don't necessarily look at the code quality in the same way. It's really, looking at the project activity, the developers themselves, and people who are actively engaged with the project, whether they're actually coding or not. So they might be, reporting bugs. They might be clicking the star button. They might be watching the project, which means that they're getting, constant updates on the project, which is a really kind of active way of being involved without actually submitting code yourself.
So you're measuring how people are interacting with these with the open source projects using GitHub as a repository.
Yeah, exactly.
And then so then you got the data and you did some analytics on it.
Yeah, that's right. So I identified some key metrics for success based on what was out there in the literature. So things like the number of core developers that were working on a project, the number of bugs that were reported against the project, the number of releases if that information was available, again, recent activity. So there was one researcher who had interviewed a number of GitHub developers, some well-known GitHub developers, asking them what was making GitHub itself so attractive as a hosting platform. And they were really saying that it's the transparent nature of the platform, and they came out with the fact that you can actually see how often a project has been updated, and the most recent activity is really important to them when they're actually going to contribute to a project. Things like they wouldn't even look at a project if it hadn't been touched in more than 6 months. And different metrics like bug fixing speed, and also more kind of community-based metrics such as the user reputation. So like the reputation of the developer, of the people who were logging the bugs, as well as the sociability, sociability factor. So looking at how many people they were actually interacting with in GitHub. So this was another researcher had kind of come up with this idea of outdegree, and it was measuring the kind of network that different developers had kind of built up within the platform itself.
So it sounds like the things that you're talking about are all sort of gamification sort of factors.
Yeah, I suppose you're kind of getting a reward maybe. Yeah. I mean, if you're kind of, I mean, gamification, I suppose if you're looking at the stars and watching and constantly updating your project, I think you could look at it that way as well.
So, Sarah, which metrics do you find most useful in terms of determining the project success?
Yeah, so I mean, once I determined a list of metrics that were suitable for the GitHub projects, I was able to actually run some analytics on it, and I used the SVM algorithm once I had matched the metrics up with the projects that I had and had produced a labeled data set. And what came out of that was that the most important or the most statistically significant metrics were the number of core developers and also related to the number of watchers. So I think this kind of displayed that, it's based on the actual developers, they're really important in a project, especially an open source project, but also people who aren't necessarily developing, you know, they're the people who come along and they want to watch, and but it's not just pressing a like button, they're actually getting emails, and you know, no one likes spam, so you're really only going to sign up if you're actually really interested in a project. And so I thought they were kind of interesting metrics for success.
Awesome. And anything interesting that you found? What was the most surprising thing you found from the project?
Yeah, so when I was looking at the projects from a historical point of view, so the kind of predictive aspect of the project, what kind of surprised me was that the number of commits actually had no statistical significance whatsoever, which I thought was interesting, because I know there has been kind of maybe kind of anecdotal evidence that people, you know, they split up their commits into hundreds of small commits just to up that number, you know, on GitHub, and I think on SourceForge actually that was maybe something that was a metric that was measured quite strongly, so that the number of commits that was placed in your project was something that, you know, was a good thing. Whereas when you look at it now for GitHub, it's not necessarily, you know, if you've got thousands of commits, I guess it's based on the type of code you're committing, rather than just the fact that you're committing, you know, thousands of lines.
Very good. And we talked earlier about text analytics, that you could you have folded any text analytics into this project?
Yeah, so I mean, I was just looking at GitHub as the repository for the data and all the metrics that you can find there. But you could expand this to Twitter, and you could look at the users that are interacting with the project on GitHub, and then follow them onto Twitter, and try and see if maybe they're talking about the project, you know, what their feeling is about the project, you know, by analyzing their Twitter messages, or, you know, indeed on GitHub itself you could read maybe the issues that are reported, and, you know, try and do you know, find out exactly how angry maybe a user is that something has gone wrong with the product, or find out maybe they're actually just asking for change requests and updates, rather than constantly, you know, logging issues and problems and having problems with the actual software.
So what was the impact of the research?
Yeah, so I guess there's kind of 2 points to the research. So the first one is, you know, the data set that I use to measure the current health of a project, and this would help any developer who has an open source project to, you know, collect the metrics about it and run the ranking algorithm, so that they can actually rank their project maybe against competing projects, and see how they're doing, how the current, you know, what is the health of their project right now in relation to other projects. Then there's the kind of historical prediction side of the project, where if they took the first 18 months development from their project, and collected all that data and fed it through the process that I have, then we could maybe predict, you know, in future, will this actually be labeled as a successful project or not? You know, are we on a trajectory for success here? And, you know, if not, you know, take action, you know, look at the metrics that you're slipping, and, you know, find more developers for your project, or, you know, increase your own network if it's just yourself. You know, look at the issues. Are you fixing your bugs fast enough? Do you know, do you need to promote your project more? Do you need more stars? Do you need more people to watch your project, you know, to gain interest?
Cool. So if I want to find out more information, where would I go, Sarah?
Okay, so obviously this is very much based in GitHub, so I have my own GitHub repository, and on there is the thesis, and there's the ranking algorithm, so you can use that, and there's a whole load of code there as well. If you're interested in pulling that down and reusing that, that's no problem.
Sarah, it's been an absolute joy. I'll put the links with the video on YouTube. Thanks so much for joining us. It's been absolutely fascinating.
Thank you, Sarah.
Thank you. Thank you very much.